this week. So as you may or may not be aware, we are just about at the halfway mark of term 3. So we are at the beginning of week 4 and a total of 8 weeks in the term. So after this week, we will be halfway through this term, which seems crazy because I feel like we're just starting to get started. But anyways, regardless, since we are halfway through, that means that we have our first exam coming up, our midterm exam, or IPC. So for the midterm, it essentially is structured like a really big version of your daily assignments or daily questions. So there's a Google Form version, there's a Google Doc version. Some of the main differences, though, are that the material on this midterm could be anything from the first 4 weeks of the course, including the stuff that we're going over today and on Thursday. So going back to the solids and liquids and gases and the chemical physical properties, the atoms, the electron shells, the metals and metalloids, and then including this week with the compounds and mixtures and the chemical bonds, all of that is going to be covered or could potentially be covered on the midterm. So because of that, because there's a lot of information on there, it's not just open and closed on the same day. Instead, it is going to go up tomorrow morning, so Wednesday morning. But as you can see by the title, it will not be due until the end of the day on Friday. So you have 3 whole days to work on the midterm. You have all day on Wednesday, all day on Thursday, and all day on Friday if you need it. Like I said, the midterm is a little bit longer than most assignments in here. It's about 20 to 23 questions long, I believe. And it's also worth a lot more points. So it makes up a little bit bigger chunk of your grade than the other assignments as well. So I definitely recommend taking your time going through it. Make sure to read each question carefully. There are a lot of people who on the previous worksheets or on midterms in the past have missed some points here and there because they didn't fully read the question and they didn't fully answer what the question was asking. So make sure you have 3 whole days. So take it slow, read each question, and be sure of your answers. As always, if you get stuck at some point, you can always reach out to me for help. Obviously, since it's a test, I can't directly help you answer the question. But if you're just like totally lost, totally confused about what the question is asking, or you're like, I don't really know how to answer this question, I don't really know what type of answer this question is looking for, that is the sort of stuff that I can help you out with. I don't remember, there's something else I was going to mention, but it'll come to me later. So the midterm is set up, like I said, pretty similar to the worksheets and stuff that you've been doing. On the Google Doc version, you can either like write in or highlight or bold the letter of whatever answer you think is the best answer. But there aren't just multiple choice questions. There's also fill in the blank style questions. There's short answer style questions. There's ones where you're going to be looking at some images, some periodic table stuff. There's some labeling type questions. There's some other, again, some more short answer questions. And so a whole bunch of different varieties of questions that you're going to be answering. The Google Form version, just like before, has all the same questions in the same order and all the same answer choices. It does look a little bit different because instead of having like one huge long page of questions that you're going through, I have it kind of separated out into chunks. So after you put in your name on the first page, instead of being a submit button down here, it says next. And then you have the next set, or kind of like the first set of questions. I think there's like 9 or 10 questions in this first section. And then once you fill all those out, you'll hit next again, and it'll bring you to another set of questions. I think there's 2 or 3 sections. And then at the end, as always, there's the button that says submit, where you'll click on it and it'll send me a notification saying that you completed the exam. So exact same questions, exact same answer choices in both versions. So it's up to you to complete whichever one works best for you. Again, since it is an exam and it is a lot more questions and a lot more material than in most of your like daily assignments and stuff, you have Wednesday, Thursday, and Friday to work on it. You can go back to your notes if you need some help. Obviously, since you're taking this on the Google Classroom, you have the Google Classroom available to you. So if you want to go back and read through some of our old notes that we did before on the electron shells or the protons and neutrons and electron stuff, actually that's the assignment, there's the notes. You can do that. If you want to go back and watch the videos of us going through the material before you answer a question, you can do that as well. So all of that is available to you over the course of Wednesday, Thursday, and then Friday is the kind of day to get it turned in. All right, so like I said, the midterm will be initially posted tomorrow morning. So just like how all your other assignments are, it'll be posted right in the morning. And then you'll be able to work on it throughout the day and throughout the next couple days as well. All right, so I wanted to make sure to mention that up front so that you're not shocked or surprised by it when you see midterm exam popping up on your feed on Wednesday. So does anybody have any questions about what the midterm is or how to work on it? Any questions about anything like that?
I have a question. Just tomorrow you're gonna post it, right? Or tonight?
Yep.
After
Yeah,
12?
tomorrow morning.
Okay, and do we gonna have like an assignment too?
Yeah, so besides the midterm, you'll still have your daily assignments for today and tomorrow and Thursday. I tried to make them really short and easy to complete so that it wouldn't take too much time away from being able to work on the midterm. So yes, there is still a daily assignment for Wednesday that you can do in order to get your attendance counted. So make sure to not forget about that. Great question, Nasima. Thank you for reminding me.
Yes, thank you.
All right, good question. Any other midterm or class-related questions before we get into the notes for tonight?
No.
All righty. All right. So like I was saying a little bit earlier before we were getting started here, today we're going to be looking into kind of the different ways that we can mix and match our atoms. There we go. Yes. So up until now, we've been really focused in on the atoms themselves, looking at like how many protons do they have? What is a neutron? What sorts of stuff are in the nucleus? What does the atomic number of an atom mean? Where do all the electrons go on the electron shells? What's the difference between a metal atom versus a non-metal atom? All sorts of stuff like that. Today, though, we're going to kind of break down what are the different sorts of combinations of atoms that we can get. So no matter what sort of matter we're working with, no matter what sort of atoms or substances that we're working with, depending on how they're arranged and how many different types that they are, scientists have kind of different categories that we put these atoms into. And so I'm going to start off by showing you kind of the whole breakdown of everything. It's probably not going to make a whole lot of sense to you to begin with, but then we'll kind of go through each piece one by one and talk about what makes that piece kind of unique, or what are the characteristics of that one piece of the atoms. So there's kind of two major categories of matter that we're going to be dealing with. Again, remember, matter is just the scientific word for like stuff or things out in the universe. And so we can classify our matter as being a mixture of all sorts of different types of matter, or a pure substance where there is only one single type of matter present. We can further break down our mixtures into two different types of mixtures called homogeneous and heterogeneous, that have to do with how evenly everything is mixed in. And we'll talk about these guys a little bit later on. But if we have a pure substance, we can sort of classify pure substances as either compounds, multiple atoms together, or elements, one single atom on its own. So again, this probably is a whole bunch of information you haven't seen before, so don't really worry about it right now. Instead, we're going to sort of take this one piece at a time. So we're going to start off talking about pure substances, and we're going to break down what does it mean to be an element versus a compound. So a pure substance is when there is only one type of particle, one type of substance that is present. Later, we'll look at examples where we have all sorts of different stuff all combined together. But in a pure substance, we only have one type of particle or like atom that is there. Right? So a pure substance is pure. There's nothing else that's mixed in, nothing else that's combined. It is purely one thing. So our pure substances, we can break them down into, are they just one atom, or are they one combination? Are they one particle type? So if it's just one single atom, we call that an element. So like here, this sort of basic example, we have these little black dots that represent atoms. And this is the only type of particle that's in here, right? There's no other type of atom at all, just these black dots. So we would call this substance an element. Over here, now we have two different atoms. We have the white dot and the black dot. But those atoms are combined together. So every single particle, every single compound in here is one black dot and two white dots. So even though there's different atoms that are here, every single particle, again, we're looking at particles, every single particle is the same. So it's still a pure substance, But instead of being just single elements, now it is a single compound. So every single particle in here is a 1 black, 2 white compound. So that's sort of the basis for this division. And we'll talk about the difference between these a little bit more in a second. But elements is when there's one single atom only. Compounds, you can be some different atoms, but every single particle, every single little piece has to be the same thing, made up of the exact same combination of atoms. So a little bit more about elements. Again, this is when we have identical atoms. Every single atom in this pure substance is the exact same. So for example, maybe you have a copper vase. So copper has a symbol of Cu. So every single atom in this vase is a copper atom. There's no oxygen atoms, there's no hydrogen atoms, there's no carbon atoms that are mixed in here. It is all 100% pure and only copper. We can also have particle or pure substances like gold, like these gold bars down here. Gold is one of those weird chemicals where the name is gold, but the symbol is Au. Don't ask me why. It's a long, boring explanation of why that is. But again, every single atom, every single particle in this gold block is a gold atom. There's no nitrogen mixed in. There's no helium that's mixed in here. There's no like zinc or tin or any of those other metals. It's all 100% pure and only gold. So element is when we have one single atom, one single type of atom, and that's it. Again, one single type, only these black dots, only copper atoms, only gold atoms, whatever it might be, there's only that one single type. So a lot of times it's pretty hard to get every single atom in your substance 100% pure and 100% the exact same atoms. Most of the time, you end up with different atoms that combine together in order to make a compound. So a compound is when you have two or more different elements bonded together. So whether or not this is like that example we were looking at a second ago, we had like the black dot and the white dots that were bonded together. Things like salt. So salt is a pretty common compound in our daily life. And salt is made from a sodium, which is the Na down here, and chloride atoms. So sodium and chlorine atoms together, when they bond together to make a compound, we call that compound salt. So the key is that there's different elements. There's not 100% sodium or 100% chlorine in this salt. It's a 50-50 mix of both of those. And that's what makes it a compound. Every single salt molecule in this shaker is a sodium and a chlorine atom that are bonded together, that are stuck together. And on Thursday, we're actually going to talk about exactly how those bonds happen. But today, the main thing to know is that they're bonded together, and that's what makes them a compound. So these white and black molecules are bonded together. They're different atoms, but they are together, and that's what makes them a compound. And again, as long as this compound is the only thing that is in your substance, it's still a pure substance because there's only this one single type of particle. So compounds surround us in pretty much every single aspect of our life. And you may not have even really thought about it or realized it. But some other extremely common compounds that you deal with on a daily basis besides salt are things like water. So water is 2 hydrogen and 1 oxygen molecule that are together. So this is kind of like the example that we were just looking at earlier with the little dots. So it's like 1 black dot for the O and 2 white dots for the H. And again, if this glass had 100% pure water, no sugar or minerals or electrolytes or anything like that added, if it was only 100% H2O molecules, then it would be considered a pure substance. Carbon dioxide is another example of a very common compound. It comes out of your mouth every time that you exhale. It comes out of the exhaust port of your car when you drive it around. It's coming out of these factories. It's in the atmosphere around us. It's a natural part of Earth's atmosphere. And again, we have 2 oxygen and 1 carbon molecule together. This would be kind of like if we had 2 black dots and 1 white dot that were all stuck together. They're different atoms, right? C and O, carbon and oxygen, are not the same thing, but they're combined together, they're fused together to make this compound. Another one that a lot of people are very familiar with and very happy to see enter their lives is ethanol, which is the type of alcohol that is in our alcoholic beverages. So things like beer, wine, tequila, rum, they all have ethanol in it. I specify ethanol and not alcohol because there's a lot of different types of alcohols out there, but ethanol is the one that is relatively safe for us to drink in moderation. Ethanol is a little bit bigger compound. It's got 2 carbons with 5 oxygens attached to those, and then an oxygen and hydrogen group, an OH group on the end. So again, these are all different atoms, right? And this now we have 3 different atoms, C's, H's, and O's. But they're all fused together, they're all combined together in order to make ethanol. So every ethanol compound out there has this exact same structure, this exact same set of atoms. So compounds, different atoms, but they have to be fused together is the key. If there are just a whole bunch of different atoms that are just all combined together and floating around, that is not a compound. A compound has to be different atoms that are stuck together. Also, not a compound would be if it's the same atom stuck together. So sometimes you can have like 2 H's that are on their own or 2 oxygens that are on their own, and that would not be a compound. Again, different elements together is what you need in order to make a compound. All right, any questions about compounds or elements or pure substances so far?
No.
No.
Okay. So that was looking at what are kind of the different types of individual particles that we can have when they're on their own. So we can have elements, and if we have only elements, that's a pure substance made of elements. If we have a compound with different elements, if there's only one compound there, like it's just pure H2O or pure CO2, that would be a pure substance. But what about if we have lots of different elements or lots of different compounds that are all combined, all mixed together? Well, we can't call it a pure substance anymore because it's not. Instead, we call it a mixture. So a mixture is what we get when we combine two or more pure substances. So we get lots of different particles all mixed together. Hence, they're mixed, so they form a mixture. So here we have this black dot and this white dots and these black and white dots. So this black dot right here, would this be an element or a compound?
Element.
Element, exactly. It's one single atom, so that we have one element that's in here. What about this black and white guy that we have right here? Two white atoms bonded to a black atom. Would this be a element or a compound?
Compound.
Compound, precisely, because we have different atoms that are fused all together. What about, so this one's a little bit tricky question. What about this guy right here? We have two white atoms that are fused together. Is this an element or a compound?
Element.
Yeah, element. Exactly.
Because two are the same.
Exactly, Nasima. They are the same. So it's a white particle and a white particle that are together. So they're not different. So it's not a compound. It is an element. Good, very good. So because we have all of these different things together, we have this one black element, we have this two white element, we have this two white, one black compound, all combined together. It is called a mixture. It is no longer a pure substance. If it was only this black element, or if it was only this double white element, or if it was only this black and white compound, then it would be a pure substance. But it's not. It's all three of them all combined, mixed together. So we have a mixture on our hands. So there are two different ways that we can classify mixtures. We can classify them as being extremely equally and evenly distributed, or we can classify them as being very unequal and clumpy and spread out and stuff. So the first one, where everything is equal and even, is called a homogeneous mixture. So a homogeneous, or some people phrase it as a homogeneous mixture. So this is when all of the elements and compounds that are mixed together are all totally evenly and equally distributed throughout the mixture. So there's the same amount of elements and compounds in each area of the mixture. This tends to happen when you have a few very small particles, so compounds that are not very big or elements that are not very big, which helps them to be very evenly and equally mixed around. So when you hear homogeneous mixture, I want you to think equal and even. So I'll go through a whole bunch of different examples of homogeneous mixtures to kind of get you to see what I mean by that. The main takeaway is that in a homogeneous mixture, every single piece, every single drop, every single chunk of that mixture should be the exact same. Since all of your particles are evenly mixed, that means each time that you get a piece of that mixture, it has the same combination and the same amounts of particles as all the other pieces. So for example, in like eye drops, like a saline solution for your eyes, every single drop of the eye drop should have the same amount of water and salt and medicine in it to help out your eyes, right? You don't want the first drops to be like really, really powerful, but then by the end it gets like super watery and it doesn't work so well. If it's a homogeneous mixture, they're also sometimes called solutions. then every single drop should be the exact same from start to finish, because every single drop has the same even components, the same even distribution of particles in it. Same thing with things like mouthwash. So again, similar to our saline example, every time that you gurgle and rinse some mouthwash around in your mouth, it should be the same mixture, the same combination of the like water and mint flavor and alcohol, if it uses a little bit of alcohol, and whatever antiseptic stuff that it has in there. So every single time that you wash your mouth with it, it should feel the same and have the same ingredients. Same thing with vinegar, which is basically just a combination of the compound acetic acid and water. So every single capful, every single spoonful of this vinegar should be the same, right? There shouldn't be, like the first one shouldn't be super watery, and then as you get to the end, it suddenly gets really strong and powerful. That would mean that not everything is even and equal, but we know that it should be. Things like coffee, if you make it in a drip coffee pot, so like your traditional one where you put the beans in the top and then the water comes through into the coffee pot, every single pour of this coffee, every single piece of this coffee should have the same mixture of like water and coffee flavoring and caffeine and the other molecules and chemicals that come along with drinking coffee. So this isn't true for every coffee maker. I don't know if you guys, my wife is like super into coffee, which is fine by me because I don't drink the stuff, it's gross. But she has all these different devices to make coffee all different ways. One of them is called a French press, which if anybody's ever heard of it.
Yes, like, I have one.
Yeah, and so you mix the water and the coffee grounds all together in there, and then you use a little plunger to push all the coffee grounds down into the bottom to keep them away from your mouth because you don't want to drink them. That would not be a homogeneous mixture because now you've got all these bunched up coffee grounds down at the bottom of your big coffee cup, your big coffee container, your French press. And so now you have all of these pieces of coffee ground, pieces of coffee bean at the bottom, and all of the liquidy part of the coffee at the top. So that would not be homogeneous. That would be the other type that we're talking about now. But if you do it the kind of traditional way where you have the coffee beans all held away and filtered out, then you've got an equal and even mixture of water and coffee. Another really good example is peanut butter. So peanut butter is a combination of basically crushed up peanuts and a little bit of oil and a little bit of sugar. And so I'm a big peanut butter fiend myself. I love peanut butter, especially for like sandwiches and stuff like that. And so every time that I make my peanut butter and jelly sandwich, every single scoop of peanut butter from the start to the end should be the same. It should have the same combination of oil and sugar and crushed up ground peanuts. Sometimes if you get like super fancy peanut butters or like the like super all natural peanut butters from like Whole Foods or something, sometimes you have to mix them before you eat them because the oil will separate out and sit on the top of the peanut butter. It's gross, which is why I don't get those ones. I'm fine with some tasty, delicious Jif. But some of those ones you have to kind of like remix every time you open it because the oil comes out and sits on top. So that would make it not a homogeneous mixture because then you have all the oil on top, which is away from all the other stuff in the bottom. So it wouldn't be evenly and equally mixed. But in most like kind of traditional store-bought like HEB brand or Jif brand or Skippy peanut butter, it's going to be all totally homogeneous, all the same combination, the same distribution of peanuts and oil all the way through. So that is our homogeneous mixtures, everything equal and even. We can also have the opposite of that, where things are unequal and uneven. We call these guys heterogeneous mixtures or heterogeneous mixtures, however you want to say it. So in a heterogeneous mixture, now things are uneven. Not everything is equal. You may have more of one type of compound over here, more of another type of compound over here. The atoms down here are really, really spread out from each other, but the atoms over here are really, really closed in and crunched up with each other. That would make it a heterogeneous mixture. Not everything is 100% the same. So some areas might have particles that are really clumped up together. Other areas may have particles that are really spread out from each other. So like this picture of granite right here. So granite is a rock. People really like having polished versions of it as like in their kitchen for countertops and whatnot. And granite is a very heterogeneous type of rock. If all of the different minerals and stuff was equally distributed, you'd see just kind of like a blank gray rock being presented, but they are not. Lots of different types of minerals and particles clump up together. And that's why you have some areas are black, some areas are white, some areas are more gray, some areas are kind of more brown. All of these different little colors are popping out in all these different places because that's where certain minerals are clumped up together. And so you can see them more easily. So all of these tiny little clumps of particles, all these little tiny little clumps of minerals tell me that this is not homogeneous. This is not equal and totally even. There's an uneven distribution going on. Not everything is 100% totally the same. So other kind of good sort of everyday examples of heterogeneous mixtures that I like to think of is something like a salad, right? So if you're eating a big salad that you make at home or get from a restaurant or something, every bite is not going to be the exact same, right? Some bites might have, so in this salad, for example, we've got some, it looks like some spinach, some, I don't know, pineapple or mango, some blueberries, some strawberry, and maybe like some almonds and some feta cheese. So each bite might have a different combination where some have a lot more spinach in them. Some of them, you get a lot more fruit, like this raspberry and this mango. Some of them, you might get a big clump of cheese that's in there that you didn't get in your other bites. If you toss it in some salad dressing, some pieces might have a little bit of salad dressing on them. Some might have a lot on them, but not every bite is going to be totally equal, totally the same. If you wanted to do that, you'd have to take your whole salad and stick it in like a blender or a food processor or something and blend it all up so that everything just turned into a greenish, reddish mush. And probably taste not great and it'd look even worse, but it would all be even. But if you keep it in its normal, traditional, pretty looking salad form, it's going to be a heterogeneous mixture. All the pieces of the salad aren't totally evenly distributed. Like right here, there's more blueberries than over here. And this edge has a lot more spinach than over here where there's a lot more fruit. So you have more of one thing in one area, less of other things in other areas. It's all unequal and uneven. Even on a smaller scale than this, if you just look at like a salad dressing, like the zesty Italian dressing right here, you can see the base of it looks like mostly a mixture of like water and oil, maybe. But then you've got all these little chunks of garlic and red pepper and maybe some other stuff floating around in there as well. So because of all of these little chunks, it is not an even mixture. It is a heterogeneous mixture. All of these different little pieces are more closely clumped up in one area versus other areas. There's might be little pieces of red pepper in one area and big pieces of red pepper in the other area, but the pepper and the garlic are not completely evenly mixed with the water and the oil. There's more of some in these clumps and these little pieces in here, so it is not even and equal. It is heterogeneous. And then a final example, even if you go outside to where you can find some dirt and you reach down your hand into the dirt and you pull up whatever you get, you're not going to get a totally even mixture of a clump of dirt, right? Maybe you'll find some sticks in there. Maybe there'll be some rocks in some places. Maybe in one handful you pulled up a worm, and in another handful you got some beetles or something running around. Even in the layers of the dirt, it's different. So this top layer of dirt has a lot more soil and a lot kind of finer soil mixed in, whereas maybe these lower levels are more kind of clay, like thicker and more clumpy. So even the dirt itself is not evenly mixed. We have this dark layer and then this kind of medium layer and this lighter layer down on the bottom. So it's not totally evenly mixed together, evenly spaced out. It is unequal and uneven, which makes it a heterogeneous mixture. So again, it's a mixture because we have lots of different things all being combined together into one bigger piece, whether it's a salad or whether it's the dirt. But when we are heterogeneous, that means that we have uneven, unequal mixing. If it's homogeneous, that means everything is equal. All the different particles are all mixed together equally. There's equal amounts. They're distributed throughout the solution evenly. That's what makes it homogeneous versus this unequal, uneven mixture. All right. So does anybody have any questions before we move on mixtures, on homogeneous mixtures or heterogeneous mixtures?
No.
Fine, thank you.
No.
Got it. Don't worry too much if you can't spell this or you can't say this. That's not going to be part of the test, I promise. They're long words, and even I, who've been saying them on and off for the last year and a half or so that I've been teaching this class, I still get them mixed up in my mouth sometimes. All right, so now if we look back to our flow chart with a little bit better understanding of kind of what's going on, don't necessarily worry about where it says like separated by physical means or decomposed by chemical means. We're not really going to get into what exactly that means here. Main thing to remember is that our first separation is essentially, is there only one type of particle present, or are there lots of different particles all mixed together? If we only have the one type present, that is our pure substance. It is pure 100% whatever that compound or element is. If we do have lots of different compounds and elements that are all combined together, that's when we have our mixture. So if we have a mixture, we can have homogeneous mixtures where we have lots of different, or we have all of our particles are all kind of very evenly and equally distributed throughout the mixture, versus a heterogeneous mixture, which is when we have big clumps of things in one area and there's a lot less of things in another area. And so all of our compounds and elements are not equally divided, equally split. On the other hand, if we have a pure substance, that means that we can only have the one single type of particle that's there. If we have multiple different atoms that are combined, that are fused together, that is our compound. And then if we have just one single type of atom on its own, that is an element. So mixtures can be made up of a combination of compounds and elements together. So maybe we have 2 or 3 different compounds, or we have one compound and one element that are being mixed together. And that's what gives us our mixture, whether it's homogeneous or heterogeneous. But if there's only one compound or there's only one element, then it is a pure substance. That's the only thing that's there. That means that it is pure. It's pure substance. There's no other compounds or elements that are mixed in with it. All right. Any questions before we move on anything related to mixtures, pure substances, compounds, elements, any of that good stuff?
No.
All righty. So the last thing that I wanted to kind of do with you guys before we wrap it up for this evening was to kind of do a little bit more showcasing of some of these different types of compounds and elements through the drawing of the little particles, because your homework, your assignment that has to do with this is going to ask you to analyze some different pictures and tell me if it's a compound or an element or if it's a mixture of some kind and what kind of mixture is it. And so all right, let's see here. So we've got our little whiteboard here. And
So do we have to answer here with you, or we have to open? Oh,
nope, you can just kind of watch and follow along.
okay. Thank you.
So we've got our elements and we've got our compounds. And the main thing to remember about these guys are an element is when it is only I'll change that a little. Only one type of atom. So sometimes it might be just kind of a single atom on its own, or maybe it is multiple of the same type of atom that is together. Either way, all of these on their own are still elements, right? It's just a one single type of atom. Compounds, for a compound, you have to have different atoms, and different being kind of the key word here, that are fused this is not going to fit together. So like we saw before, we had like the one that looked like this.
Mr. Mike, what is this atom, and what is this?
It's different atoms fused together.
Used, yeah, thank you.
So it probably would be easier to make like a little, well, no, too late now, going forward. So we could have something like that. We could have something like this. We could have something like this. Again, these are all different atoms that are fused together. So in some of the examples we were looking at, we had things like water, which is H2O. So we had two H's that were both fused to an oxygen molecule. We had CO2. So it's like a C with two O molecules. These are all compounds. And so we can make pure substances out of single elements or single compounds. So if it was just this guy on his own, that would be a pure substance. Same thing if we had like just this guy on its own. So if we had 20 of these type of compound or 100 of these type of compounds, and that was the only thing that was there, that would make it a pure substance. It only becomes a mixture when you start mixing and matching different types of compounds and different types of elements. So if you had some sort of substance that was like this and had these two compounds together in it, now we have a mixture because this compound is different from this compound. So since they're not all the exact same particle, we have a mixture. We no longer have a pure substance. All right. So the reason why I wanted to kind of bring this guy up and show it to you guys in this way is because the daily assignments for today and tomorrow are focused on kind of these pictures of different substances based on these like very simple little black and white drawings. So we'll go take a look at those really quick here. So if we look at the assignment for today, the first part of it is kind of a review of some of the stuff that we were just talking about. If you need kind of a refresher, if you go back to this a little bit later. So we have our elements, whether they're single atoms or double atoms. We have our compounds where we have multiple different atoms fused together. And we have our mixtures of all sorts of different atoms and compounds and molecules all combined together. So it even gives you a nice little example of a homogeneous mixture where on this one, you can see all of the white elements and the black elements and the black and white compounds are all, for the most part, pretty evenly and equally distributed. There's about the same number of them, and they're pretty much equal in terms of their distribution, right? There's not a lot more of one type of particle in one area versus another, versus over here in the heterogeneous mixture, now we have all of the black elements on the left, and all of the black and white compounds are taking up the middle, and all of the white elements are over on the right. So now this is a very unequal distribution, right? All of the particles and elements and stuff are all kind of clumped up together in their own different sections in here. So that's what makes it heterogeneous. They're not uniform and not equal. There's clumps and spacing out that is unequally distributed. So for the actual homework part, there are, I think on this first one, there's 2. So today's assignment has 2 pictures. Wednesday's assignment, I think, has 3 pictures, but they're both set up basically the same. So we have a picture of some sort of unknown substance. And for each substance, I want you to tell me 2 things. I want you to tell me what type of mixture it is, whether it is a pure substance or a homogeneous mixture or a heterogeneous mixture. And I want you to tell me what type of particles are present. Are there only elements that are present? Are there compounds that are present? Or are both elements and compounds present? So that's what the both means down here. So we have our first substance and our second substance right here. And then for Wednesday's assignment, for tomorrow's assignment, it'll be the exact same setup, but with 3 new substances. So that is what the Google form version of this kind of looks like. The Google Docs is similar, but you just have to write out what type of substance it is. So instead of having those kind of choices laid out, I just wrote down that on the first line, you have to write in if it's a pure substance, homogeneous mixture, or heterogeneous mixture. And then on the second line, write in if it's made of elements, is it made of compounds, or are both elements and compounds present? All right, and then again, also, for Wednesday's assignment, it's the exact same setup, but with 3 new substances. All right. Any questions about the homework coming up for today or tomorrow?
No.
No.
All right, cool. So again, I'm trying to make those pretty short. The first one is just those 2 substances. The second one is only 3. So that way it should be pretty easy for you guys to hopefully get started working a little bit on the midterm on Wednesday and Thursday and Friday. So again, it'll go up tomorrow, but you have until Friday to work on it. So take your time, make sure to read the questions carefully, and feel free to go back to the Google Classroom for help, whether that's notes or videos or reaching back out to me.
Okay, thank you.
Mm-hmm.
Thank you.
Let me go back to the thing. Here we go.